We're going to talk about 1 and 2 proportion tests. Let me go to the slideshow. All right, so for 1 proportion test, so when I'm saying proportion, I'm talking about percentages or fractions. I'm talking about something that is not with the means or the averages. So a 1 proportion test allows us to compare a sample to a population. Again, we've done this before with mean test, but we're going to use a proportion or a percentage in a scenario where one event has happened or not happened. So usually the proportion or percentage is given to us. You also can have the data, and I'll show you how to work with that. If you're not giving the portion or the percentage, you're going to assume it's 50%. And why isn't that? Because remember when we think back to binomial probability, when we did those where there was a random event happening. So think of a coin toss where you have a 50% chance of getting a head and 50% chance of getting a tail. So again, if you don't have the proportion, you're going to think it's 50%. For this class, I'm always going to give you the proportion. I'm just going to do it. I don't want to make it any harder on you. But no, in the real world, you could run into scenarios where they don't give you a proportion. So just assume 50% and go from there. So the P will be the proportion of the event is occurring. It's not the same as the p-value. It's totally different. So think of P for proportion, and when we call p-value, remember that's probability value. We just give it the word p-value. Q is the proportion of the event not occurring. So parameters for a 1 proportion test is got to use a simple random sample. The population is at least 20 times as large as the sample. Individuals in the population are divided into 2 categories, and the value of n times PO and n times 1 minus PO is at least 10. You don't have to worry about it for this class. I will take care of that for you so your data works out. But in the real world, the smaller your samples, a lot of times you can't do this. It's going to take things that you can't do, and you have to be careful of that. Okay. So summarize versus raw data. So we're only going to be looking at summarized data for this class, but you can use raw data by adding up the total sample size and the numbers of a certain group. So for example, if I want to know if 35% of people who support new streetlights, I pulled my area and got the following results using yes and no. So you can see all my yeses, my nos. So then what I do is I count up my yeses, which I got 21, and I count up my nos, which I got 12. So then I can use that data in Minitab. So 21, I want to know if they support it. So 21 out of my 33 votes are in support of the street lights. So then from there, using that 21 out of 33, I can test to see if 35% support the new street lights. Distribution. Okay, we've seen distribution before. This one's just a little different. We use a capital P with that little sign at the top, approximates the normal, where comma is P. And remember, per P for this is the proportion of the event occurring, not the p-value. And Q will be the proportion of the event not occurring. So how do we do that? I'm going to show you right fast how we do that. So this one is 1 minus P, okay? That's how that is. So that's 1 minus P. That's what that is. So Q is 1 minus P. So if my proportion was 35% in my last one, my Q is going to be 65%, because if I convert 35 to 0.35 and I do 1 minus 0.35 equals 0.65. And N is my sample size. And we'll do some of these, and we're only going to do these for 1 proportion test. All right. This is just a review of what you learned again before when we looked at 1 proportion hypotheses test. Okay. You can have left-tailed test. And the way we write that is the symbols have not changed for the less than or greater than or equal to. All that has changed now is we do the proportion, or we do that P before instead of the mean. You should have already seen this when we did the hypothesis testing. Same thing as mean testing. The only things that have changed are our letters. That's it. Nothing more. So let's do an example. A survey indicates that 40% of employees hate their job. A local boss believes that less than 45% of his employees hate their job. The company surveys 150 employees and 35 report that they hate their job. Using a 0.10 level of significance,